Assalamu alaikum warahmatullahi wabarakatuh, and a very good morning to all. Today I will continue our math lecture on the topic of conceptualizing interactions. Okay, before I start the class, I would like to share what we're going to learn today, which is one of the important topic for you to explore yourself, especially for your project. It is very helpful if you understand the concept of conceptualizing interactions. Okay, so let me start with a simple question. Have you ever used a system that felt confusing? Maybe a website that took 10 clicks to find something, or a machine that were not sure how to operate. Today, we're going to explore why that happened and how we can avoid it by thinking like a great designer. This topic is about how humans understand and interact with the system. Okay, so great interactions is not just about button or layout, but how users think and feel. So next slide will highlight things that we're going to learn. There are three important things on conceptualizing interaction. The first one, how do we shape our user understanding? The one actually focus on conceptual model. Number two, how do we make the unfamiliar feel familiar? Okay, that one can be applied with interface metaphor. The third one, how do people actually interact with the system? And then that reflects to interaction types. Okay, we start with conceptualizing interactions. Conceptualizing design, why do designers just start building? Okay, you as a designer of the software, start designing without looking into the background of it. Okay, why don't designers just start building? Because if we jump straight into the coding or drawing interface, we design based on assumption. Okay, so the assumption was based on designer thinking. Conceptualizing design forces us to ask, okay, so what will the product actually do? Why does it need to exist? How will people use it? Is it realistic? Okay, most bad products fail not because of the bad code, but because of the bad thinking. So that's the problem. Okay, so when you look into a certain consideration, okay, I'll give you one example here. A designer came up with the idea of creating a mobile robot server as a waiters in the restaurant to take orders and deliver meal to customer. Okay, why? What's the problem that this example address? Okay, so it's because a lot of customers come at one time, and human energy are not enough. So that's why you need a robot to serve a customer in the restaurant, for example. Okay, there also need to be look into the design concern. How would it need to move to appear to be talking? What will be customer think of it? What it always be pleasure for them to engage with the robot, not knowing what it would say on each new visit to the restaurant. What it would be annoying or a fact. Okay, something like if you go to the mamak stall, you can see a robot like this. Okay, serve you maybe, okay, with a tray representing what you want to order, and tray number one, tray number two have different meal. Okay, so that's representing a robot that's served in kedai mamak. Okay, so normally before you understand the conceptualizing interaction, normally before you do the conceptualizing interaction, there will be assumption and claim. Okay, what is assumption? Assumption means that you assume something and you claim something. Okay, In this case, maybe you can write down your assumption and claim when deciding one do you prefer. Okay. Even in our life, we always make assumption and claim. Sometimes our assumption and claim was not based on facts and figures. Okay, in HCI, you need to make your assumption and claim to be more strategic and then more based on facts and figure. Then you will solve a lot of problem. Okay, so if you look into our lecture, the first thing we have to understand what is an assumption. Taking something for granted when it needs further investigation. Okay, you just say something. That one is assumption. Okay, one of the assumptions that I put here, the robot could take order and entertain customer by having a conversation with them. Okay, that assumption. Maybe the robot could make recommendation for different customers, such as restless children and fussy eater. Okay, this is a example of assumption. Okay, all right. So if you look into a claim is another things. Okay, a claim is stating something to be true when it is still open to discussion. Sorry, open to question. It will raise revenue by attracting more people to the restaurant. Okay, it will solve the labor crisis of there being not enough human waiters. The real problem being addressed, it is difficult to recruit a good staff with provide the level of customer service to which we have become accustomed. Okay, so this is what the system need a robot to serve. Okay, especially in the restaurant. Okay, working through assumption, you need to work through the initial stage of the design project. Where do your idea came from? What sources or inspiration were used, and many others. So you have to work on assumption. Then only your assumption will be strong. Okay, to support your design idea. So apart from strong assumption, they also have a poor assumption. Poor assumption means that those that are difficult to articulate. It can highlight what idea are vague or unrealistic. So this is a poor assumption that you have to understand. Strong assumption, poor assumption as well. Assumption normally came with claims. Okay, they came with claim, and then something like you related with everyone will understand how to use it, really, something like that. So when you ask something like that, you assume that everybody can understand what are you talking about. So in my case, when I give a lecture, I assume that everybody can understand what I'm talking about. Maybe I'm wrong. Okay, so in order to support a poor assumption, I have to convert this poor assumption into something that's strong assumption by giving some experiment, by looking into fact and figures. All right, so that's meaning of assumption, claims, and poor assumption itself. Strong assumption also involved to understand this. Then this slide, okay, next slide showed a framework for analyzing the problem space. So looking into a framework, you will understand something like to avoid bad design. Maybe you can ask, is there any actual problem? Okay, what is the problem? Who experience it? How do they handle it now? How will your design improve it? Okay, when you start understanding the problem space, then the assumption and claim become more clearer. Okay, so if you look into the framework, we have not many choices, but I give you a few examples after this. You have to look into the reality, okay, reality things. Okay, for example, for 3D television, people assume that when they watch television in 3D, they will be better. But actually, today, 3D television are not very popular. Okay, so maybe something wrong with the approach, or maybe because of the prices of the technology are very expensive. In order people to buy them, so they need to spend a lot of money, and it's not worth it. So there are many assumptions and claims about watching television in 3D. Okay. So assumption and claim, how realistic, okay? So if you look into the slide here, there was no existing problem to overcome. Was there, what was being proposed was a new way of experiencing television, okay? And an assumption, people would really enjoy and enhance clarity and color detail provided by 3D. So is it true? Okay, maybe not true in some cases, maybe it's true, but reality, people feel awkward when they have to wear a spectacle or third-party devices in order to see the television in 3D. Okay, that's something happening. It currently happened. So now, when we want to move from problem space to design space, we need a good understanding of problem space. Okay, that can help you in designing. Okay, before decide to design, you have to understand the problem. Okay. Now, if you look into one of the popular movie, I would like to share things about the story behind Kingfisher birds and Shinkansen Japanese train. So the design of the speed train was based on this bird, Kingfisher bird. Okay, maybe I would like to share the story. Okay, this is the story that I would like to share with you. You can see this one, right? YouTube.
With Lark, project management has never been this easy for companies. From brainstorming
through tunnels, it made a loud boom. It was disturbing to wildlife, passengers, and people who lived nearby. So
okay, the problem is when this speed train, Japanese Shinkansen train, move to the tunnel, it make a sonic boom. Because you see the train is big and then it enter into the tunnel, it make a sonic boom. Okay, that's a problem.
Why was it happening? Air was building in front of the train as it entered a tunnel. The compressed air created a sound wave, and as this left the tunnel, boom! A sound like a gunshot came out. This air was also slowing the train down, like wading through water. The kingfisher bird's long, sharp, pointed bill is perfectly shaped for plunging into water. Long, narrow, and streamlined, it steadily increases in diameter from the tip to the head. This reduces the impact when the bird hits the water. It slides in, the water flowing past the beak rather than being pushed in front of it. Exactly what the bullet train was failing to do. The train team studied the beak, which resembled two triangles with rounded edges, together forming a squashed diamond shape. And so a kingfisher's bill helped them design the train nose. When it was tested, the Kingfisher bullet train was faster, quieter, and more powerful, with 30% less air resistance than before.
Okay, so that's the main solution done by Kingfisher bird. All right, it looked interesting, and the concept of this solution was introduced in 1980 something, okay, by a case study. I would like to share with you a case study of the Shinkansen train and the Kingfisher birds. Okay, so the concept of the design was named as a biomimicry design. Okay, so if you look into the problem of this case study, it start with a high-speed train cause a loud tunnel boom. So you can imagine this is a train enter into the tunnel and bring all the compressed wave along the way, and when they get out from the tunnel, it gives a big tunnel boom. Okay, so the challenge is the Japan won faster train, more than 300 kilometers per hour, but at the same time, they need to reduce the noise and energy use. So that's a challenge. And then this is the person behind the finding. His name is Eiji Nakatsu. Okay, he's an engineer from Shinkansen train. And at the same time, he also as a bird watcher. Hobi dia, dia punya hobby is watching birds. So it's inspired by nature. So the concept of the Shinkansen train came from this engineer, Eiji Nakatsu. Okay, so when during his hobby as a bird watcher, he accidentally saw that kingfisher bird is a master of dive. When the bird enter into the water, there's no water splash, no splash during the streamline beak because of the beak design, and it's an efficient shape to reduce the pressure itself. So the big idea now, they redesign the train nose like a kingfisher beak. Okay, it actually reduce air resistance. Okay, then the solution come and they change the speed train 500 Shinkansen series into a kingfisher beak. It become more aerodynamic and nice design. The solution, the result that they gain from this innovation that based on nature, they got 30% less air resistant, 50% less electricity, no tunnel boom, and faster speed. So that's very important things to show that from problem to design solution, problem space into solution. You can see how the concept of biomimicry has been implemented into Shinkansen train. Okay, so this is something, the new one that based on kingfisher beak. Okay, the conclusion, what I can say here, nature can solve human problem. Okay, biomimicry is one of the future of design. So you can see how Japanese solve the problem. And then when we talk about conceptualizing interaction, actually biomimicry use existing model, Shinkansen use kingfisher shape, interaction design use human mental model, something that you can understand the folder, the icon scroll, also part of the conceptual interaction that we use today. Okay, so benefit of conceptualizing is can be divided into three elements. The first one is orientation. Okay, the first one is orientation. You enable design team to speak specific question about how the conceptual model will be understood. The second one is open-minded. It's prevent design team from becoming narrow focused early on anything here. I think the last one is common ground, allowing design team to establish a set of common agreed themes. So this is a benefit of conceptualizing that you can understand. And then now we go for the conceptual model. If you look into conceptual model slide here, that's supporting the conceptualizing interaction. What does it mean by conceptualize the conceptual model? Okay, conceptual model is how user think the system work. Okay, how user think, not the other round. How user think the system work, not how the actual work internally. Okay, if the user expect A and the system does B, it means confusion. Okay, by definition, a conceptual model is a high level of description on how a system is organized and operates. It enables designers to strengthen out their thinking before they start laying out their widgets. Means the widget is the application, the prototype, and many others. Okay, conceptual model provide a working strategy and framework of general concept and their interrelation. How to view conceptual model? So you can use chart, or maybe you can use flow chart. Even you can use any chart that related with component of the conceptual model. Okay, so that's one of the idea. And then we go for the component of the conceptual model. Of course, what object exists, okay? How the action map, so you can see from the flow diagram, all the component is there, connected each other in the conceptual model style. So metaphor and analogy is about understanding what the product is for and how to use it for the activities. So you can see that metaphor is a new words for you, maybe some of you. And maybe the analogy will be more general. Okay, you can imagine that you have some analogy how existing behavior works. Okay, then concept that people are exposed to through the product. Okay, like task domain, attributes, and many others. Okay, so the relationship and mapping between this component or this concept is also important. So there are three element component of conceptual model: metaphor and analogy, concept that people expose, and the last one, relationship and mapping between this concept. So how to view the conceptual model is through flowchart. It can be through many other things. So I would like to share with you another story that called screw driver and screw. Okay, this is this is screwdriver driver, and this is screw. So do you need people to understand how to use it? The answer is normally people already know how to use it by nature, isn't it? So look at the nature, you know that screwdriver is to control how to tighten the screw. So this is the same analogy. When you have something that already exists, it's easier for you to implement them. People already understand and do not need to learning how to use it and any other things. Okay. So the screwdriver and the screw is actually already have a good mapping. Insert screw and turning screwdriver. Okay. Okay, first step in formulating a conceptual model, you have to try to answer this question. Okay, what will people do when carrying out their tasks? Okay, how will the proposed model support this? What kind of interface metaphor? Right? What kind of interaction moods and style to use? So we will understand more on the next lecture on interaction moods and style. And then keep in mind when making design decision how the user will understand an underlying conceptual model. So these are the things that you need to understand well. Okay. Then conceptual model, many kind and way of classifying them. Okay. The best conceptual model are often those that appear obvious and simple. The operation they support are intuitive to use. So means that when you deal with conceptual model, you have to make it simple as possible. Okay. And then that's all for part 1. And I will come back to you on part 2.